Okay, good morning, Commissioners. For the record, Betty Staugler. I am a NOAA HAB Liaison with Florida Sea Grant and the University of Florida. Until very recently, I was your Sea Grant Extension Agent for 17 years. So today what I want to talk about is some of the in the water observations related to seagrasses and macroalgae. And I wanted to start by saying that we are really fortunate in the Charlotte Harbor area to have some really long-term data sets to look back at. So I'm going to start with the FDEP Charlotte Harbor Aquatic Preserves. And I want to thank Mindy Brown for helping me put this information together. The Charlotte Harbor Aquatic Preserves has been monitoring in Charlotte Harbor seagrass sites at 50 locations since the late 1990s. And this is, we talked about the aerial photography where you get this large view of what the seagrass looks like. This is actually done in the mask and snorkel and going out in the water and looking at seagrass. So you're getting a more refined look, but you're not covering as much ground. When the map that I'm showing here, each of these data points is where they put down a 1 meter square and they characterize what's in that 1 meter square. And the data point actually represents where they put the square at closest to shore and then every 50 meters until they reach the deep edge of the bed. So, and then each color is an aggregate of all of those squares that they put down. So that's how I'm going to be showing you the data in the next slide. They've been monitoring since 1999. They go out in the late summer to early fall, so they're characterizing seagrass at its peak growth during the growing season. Again, shore to deep edge. So what you're looking at here is Upper Charlotte Harbor, the Myakka River, the Peace River segment, the west wall of Charlotte Harbor, and the east wall of Charlotte Harbor. And one of the things that this data is really good at showing, particularly as we look down into the harbor segments, is that seasonality that Nicole talked about. So Charlotte Harbor is very color dominated because of those rivers, and so when the color becomes a light attenuation for seagrass growth. So when we have heavy rain years, we tend to see less seagrass. And you can see that in 2004, 5, when we had those heavy hurricane years. 2013 was a really wet year, and then we see Hurricane Irma and the rain that it produced in 2017. And what I want to direct your attention to is the lower two graphs after Hurricane Irma. You see in the Myakka River, we see that recovery, but on the east wall of Charlotte Harbor, we don't see that recovery. So, I mean, that was one of our triggers that this was not a natural event. It was not related to rain that we were seeing these declining trends. And so this is kind of summarizing what Nicole has already mentioned, that we know that we need some level of nutrients for productivity in our estuaries. If we don't have any nutrients, we don't have any seagrass, and so we don't have any fish. But there is an optimal amount, and when we start seeing too many nutrients, then that impacts the light availability. And the first thing that happens is we start seeing epiphytes. And so epiphytes are what's growing attached to the seagrass blades. And they can compete with the light, so they're actually shading the seagrass's ability to reach the sunlight. As we continue to see nutrients, we will start to see macroalgae, both attached and drift. And eventually, if nutrients continue to flow into our estuaries, we're left with nothing but what's in the water column, or phytoplankton. And this is what we can finally pick up in a water sample. And so we can have these issues where we're seeing increasing nutrient abundance that's not getting characterized in our water sampling data because it's not in the water column, it's actually contained in the biomass of the algae. And we know that we've seen increasing abundances in macroalgae in Charlotte Harbor because of some of the data that's been collected by the FWC Fisheries Independent Monitoring Group. So they've been monitoring in Charlotte Harbor since the late 1980s, and they've been using the same 3 gear types since 1995. And the arrows on these graphs show when those gear types became annual gear types, so as opposed to just using them during certain seasons. The gear types are really designed to catch different fish species at different depths, different size classes. But you can see since about 2012, we started seeing this uptick in macroalgae in Charlotte Harbor. And I do want to thank Dave Blewett for pulling this data together. So because of the concern of macroalgae, both characterized by some of the different agency folks and the recreational users, particularly fishing guides, I put together a citizen science monitoring program in 2019 that was focused on looking at macroalgae when the literature tells us that it reaches its peak abundance, which is in the late spring. And so typically macroalgae, and we know we always have some amount of macroalgae, and some amount of macroalgae, particularly in these winter months when seagrasses are dormant and not growing, is actually good for our estuary. But in a healthy system, come warm water, or come warm weather, seagrasses start to grow, macroalgae kind of peters out typically. And so the idea of putting together the citizen science project was that we could see macroalgae during its peak abundance, and then we added another data point in July so that we could see that transition, so we would get some seasonality between macroalgae peak abundance and seagrass growing. And so what you're looking at here is 2019 in April and 2019 in July. And you can see the E1, E2, those are the black dots, and the red dots are E2. And you can see the beginning of that significant macroalgae bloom. And the middle picture is what it looked like on top of the seagrass. And by summer, where we would normally, in a healthy estuary, have our seagrasses taking over, you can see the macroalgae continue to expand all the way down into those orange dots on the east side of Charlotte Harbor. So in December of 2020, or excuse me, December of 2019, we were still getting reports from recreational anglers that this area was still experiencing a macroalgae bloom. And so in January of 2020, I went out with the Florida Department of Environmental Protection and FWC, and we mapped visually the macroalgae along the east side of Charlotte Harbor. And that's what you see on this left-hand graph, is the relative abundance of macroalgae that we saw. And you can see that it was all the way around Punta Gorda. We actually think it probably extended beyond the 41 bridge, but it was getting dark, so we had to stop. And it extended all the way down to the Matlacha Bascule Bridge. In 2020, my volunteers were not able to get out because of COVID and the inability to social distance on a boat. But the aquatic preserves were able to add a couple extra survey locations in, and so on the right-hand side, you can see what an area just north of Pirate Harbor looked like in March of 2020. This is after the macroalgae was removed, and this is what the seagrass looked like. And then in December of 2020, we were hearing again from anglers that the blooms were really bad along the east side again, so we went back out in January, and that's what you see in that middle image is the extent of that macroalgae bloom. And this time we were able to get into some of the really back bay waters using a mullet skiff. And it was, where we typically don't monitor seagrass, and it was really bad in those back bay areas. So this is some satellite imagery that I put together. This is Sentinel-2 from the European Space Agency. They produce images every 5 days. And it's from December 2018, 2019, and 2020. And so you can see in 2018 what that area along the east wall of Charlotte Harbor looks like. This is just south of Alligator Creek, down to about a mile north of Pirate Harbor. And so in 2018, you can see that seagrass signature. In 2019, you can see we're losing seagrass. And in 2020, this is kind of what it looks like. Well, it does look a little better right now, but this is at the peak of the loss. So one of the questions that we've bounced around is, why this has persisted so long. And one of the things that we know about nitrogen cycling in estuaries is that typically, the plants will use nitrogen, so they like this ammonium form that's readily available. And then as it's as it's becoming nutrified, there's some ion exchanges of oxygen. And then the final ion exchanges is denitrification, and that's where oxygen is being removed and the end product is nitrogen gas. So it's being removed to the atmosphere where it's no longer available. And that typically happens when you have low nutrient environments. But when you have high nutrient environments, there's another nutrient cycling process that actually competes with denitrification. And that uses nitrogen as the ion exchange. So the end product is back to that ammonium. So what you're ending up with is bioavailable nitrogen that the algae can then reuse. So it's almost like this closed loop of ammonium reduced back to ammonium where it's available again. And so we have to work through this cycle of getting this extra nitrogen out of the environment. So there is some good news. In this year's monitoring, the volunteers just completed, and I want to thank Forrest Hecker, the Sea Grant Program Assistant, for pulling this data together as the volunteers were actually submitting their data sheets. We were a little delayed in getting the monitoring complete because of the red tide that was in the upper harbor, and so we did extend into May, and so it was kind of a rush to pull this data together for you. But you can see on the left-hand side at the top is that same 2019 spring data, and on the right is the spring data from this year. And there's significantly less macroalgae that we are seeing out there this spring, and so we're hoping that the seagrass are beginning to favorably respond. We do see some pretty heavy epibiont loads, so again, the stuff that's attached to the seagrass blades, and that's, just still a sign that there's a lot of nutrients out there. So this year, I do want to shift over to Lemon Bay. And so on the top left, what you're seeing is the aquatic preserves seagrass trends from the abundance surveys in Lemon Bay. And I think if you were to put the SwiftMud maps on, or SwiftMud bar graph on top of this, it's almost a mirror image of what their trends have shown over time. But in Lemon Bay, I think a lot of the details are in the data. You have to dig a lot deeper. And two of the things that we've noticed is that, one, we are seeing some shifts in seagrass species in Lemon Bay. And so that top right-hand graph is Serengodium. This is the manatee grass that Nicole was talking about. It has a lot of biomass. It's one of those seagrasses that creates very complex ecosystems. And it is also a salt-loving seagrass, and it is a seagrass that requires high water clarity. And you can see that after 2001, it took a nosedive, it started to recover, and then it started to lose again, and we're seeing a little bit of recovery there. We're also seeing that same kind of trend with the turtle grass, which is another high biomass seagrass species. And so part of the masking in Lemon Bay is this transition to haliduli, which is that pioneer species. And I wouldn't put one species value over another. They're all really important. However, it does show that there's changes in the estuary. So there's less light availability for these seagrass species that need high light, and that's important. So probably higher residence time, higher phytoplankton in certain areas of the estuary. We also know that we are seeing patchy losses, and so when we look at specific sites, we do see that. This is on the bottom, ICW 01. This is that northern site up in that area where we had significant seagrass loss, and you see that from 2016 to 2018, the bed really receded back. And then if you look at the individual abundances at that site, you also see a drop between 2015-16 and then again between 2017 and 18 with a little bit of recovery since then. So we do know that Lemon Bay has its share of macroalgae and epiphyte issues. These are some pictures that I took with Captain Van Hubbard, who's here today. Very concerned about seagrasses. He took me out to collect some seagrass for some analysis at the University of Florida. Different than what we see in Upper Charlotte Harbor. In Lemon Bay, we see a lot more drift algae, a lot more attached browns, and a lot more cyanobacteria. So the mats on the bottom that float to the surface in the spring. And that's what you see in that middle image. Those pictures were actually taken just north of Stump Pass, around Whidden Key. So this is some eyes on seagrass data. We were able to expand to Lemon Bay this year, so I only have 1 year's worth of data, or one sampling point worth of data. And you can see that we do have some macroalgae there, but it doesn't look the same as Charlotte Harbor. But we do see a lot of epiphytes in Lemon Bay, a lot of attached algae on those seagrass blades. And it is very spotty, so you really have to look at each transect individually, each site individually, and that's what I'm showing on the bottom. So this is just north of the Tom Adams Bridge. And you can see that even just along a 60-meter transect, which is 150 feet, that we had some quadrats that had almost 100% coverage of, or really heavy coverage of epibionts, and then others with very light coverage. So moving forward, there's a lot of data that we have that we can answer questions with, and a lot of projects that are coming online designed to get at more pieces of the puzzle. So, FWC, again, they've been collecting this data since 1987, and because they're characterizing the volume of macroalgae, they can, over time, look at the fish response to these episodic events of macroalgae and these regular events of macroalgae that we don't want to forget because we're so focused on these episodic events. The Charlotte Harbor Aquatic Preserves, in addition to monitoring seagrass since 1999, they've also had a very long-term water quality monitoring program in place using trained citizen scientists since 1998. And they were recently able to acquire a grant to hire Mike Wessel from Janicki and Associates to look at those 2 data sets comprehensively and hopefully identify some hotspot areas where they can look up into the watershed. And so that's really important because they haven't had the capacity to do that up until this point. With Eyes on Seagrass, we started this year collecting sediment organic matter to get at what's happening at that sediment water interface, as well as collecting the algae samples at all of our locations for nutrient pool analysis by species. So what types of nutrients and in what forms are these macroalgae using? And I know you guys talked about being able to, point to things in the watershed to be able to reduce. That would take stable isotope analysis, which we are not doing at this point. One of the reasons we chose not to, particularly on the east wall, is because we have these nutrients that continue to cycle in the environment. And when you're doing stable isotope analysis, it's really the rate of decay that you're looking at, which makes something heavier or lighter. And because it's in the environment a long time, everything's just going to look like wastewater. And it could bias the results. So we're not going to go there. But we are doing the nutrient pool, and that will help us identify, what those flavors are for different algae species. We're also looking at that nitrogen cycling. So are we seeing these areas where the nutrients are staying in the environment? And this is some work that my colleague, Dr. Ashley Smith, is doing. She received some funding to look at the nitrogen cycling in these areas impacted by macroalgae. And there's just a whole host of other projects that are coming online to help us really figure out what is happening in our system. And I know it's tough. It's really tough because we don't have those answers. So that's what I have for you today.
Commissioner Constance?
Thank you, Mr. Chairman. Just curious, what consumes epiphytes? Is there something that we can do with regard to oyster restoration or certain other species of critters that will help to flush and clean the water?
So epiphytes, it's all algae, really. It's just, some algae is attached, some algae drift, some algae are just tiny in the water column. Mostly it's going to be like little snails, small fish, invertebrates that are coming and picking them off of the seagrass blades. It's the phytoplankton that the bivalves are really filtering out of the water column. So we need all of the different critters in the estuary that's what makes a balanced system.
So snails and juveniles are...
Yeah, and small crabs, anything that feeds on little things.
Shrimp.
Shrimp, that too, yeah.
Thank you.
Other questions? I want to thank you both. I know you have more to present, but this has been great information, good and bad, I guess, but it's still, we need to have the information, and we've tasked Brandon with trying to make sure we're pulling all this information together so we can do a better job here in the future. So thank you guys for doing this. Nicole, you want to come back up and let's talk about next steps?
All right, well, thank you, Betty, for going through that. And I also